guys, welcome back to my YouTube channel. Again, my name is Rica Casabuena from ECE41 of the De La Salle University Dasmariñas Electronics Engineering Department. And for today's episode of our Robotics Laboratory, we will be having our laboratory activity number 3 entitled Control of our Servo Motor. So for the objectives of our experiment, this experiment will enable the student to first control the angular displacement of the servo motor, and second is to create a computer program user interface to send data control to our Arduino. So we will be needing the typical materials that we are using in our previous experiments with an additional servo motor for this specific experiment. So for our introduction, in this activity, we will going to control the movement of a robotic arm, but in this case, we'll be representing the robotic arm with servo motors, okay, which will serve as the joints of the robotic arm. So the movement of the conveyor is controlled through a program implemented in the Visual Studio and in our Arduino. So in this case, in our Arduino microcontroller. So the Arduino microcontroller will control the servo motor, okay? Now, the servo motors are connected to the microcontroller. So the microcontroller will send pulses to the servo motor with different waves that correspond to the angle rotational displacement, okay? Literally speaking, the angles of the servo motor. So angular data is needed to be fed to the microcontroller to instruct it to rotate in that angle. So we'll be inputting values to control the angular displacement of our servo motor. So for our experiment, we'll just have to follow these procedures. For our setup, we're gonna need an Arduino microcontroller, but you can also perform this using Tinkercad, which will I be showing later on during our experiment, okay, if you don't have your Arduino microcontroller for the actual circuit. And we just have to follow this connection of the Arduino and of our servo motor in our fritzing and in our Tinkercad. So now, let's start our experiment. So now we will be creating our circuit and our fritzing. So just gonna have to create a new file. So we're gonna need an Arduino Uno. Let's start it here. Arduino. Okay, that's an Arduino Uno. So this one, I guess. Oh no. Arduino Uno. So let's search for it here. So I think this one. Okay, or probably this one. Okay. So we'll be needing Arduino Uno, and then next one will be. So next one will be our servo motor here. So let's search for it. So let's search for servo. Okay, so here is our servo motor. So we're just gonna have to put it here. So we can rotate this servo motor in such a way that it can be connected properly in our breadboard. So here. So following our instructions, we have to connect the black cable to the ground. So let's go back to our fritzing. So black cable will be on the ground. So this black cable here will be on the ground of our Arduino here. So let's connect it properly here. Okay. And we'll be selecting the color of our wire, which will be color black. Okay, wait a moment. Okay, and then so we're gonna change the color to color black, okay, to represent the color of ground, which is typically black. So let's search for black here. Where's the black? Okay. Next one, the red cable should be connected to the 5 volts. So let's go back here again. Okay, so the red wire should be connected to our 5 volts here. So here. So let's just fix our connection. Wait a moment. Okay, this one. So black wire. We're gonna be turning this to red to represent the voltage supply. So let's just fix the connection. So let's choose wire color as red. Okay, so let's just fix it properly. Okay. Okay, here on our 5 volts. And then the yellow pin of our servo motor, the yellow cable should be connected to the pin number 9 of our microcontroller. So let's go back to our fritzing. So the yellow wire here should be connected to the pin number 9 of our Arduino microcontroller. So let's just fix it here. Okay, let's just fix the connection. And we'll be turning this wire. We'll be turning this wire to color yellow. Wire color is yellow. Okay, so that's our connection. So we can fix it here. So it will be properly connected. Okay. Okay. So that's our connection for the fritzing. So now we'll be proceeding with our Tinkercad. But before proceeding to our Tinkercad, let's not forget our schematic. So all we have to do is just fix our schematic here. So just properly lay out it so the circuit will be organized. So let's fix it here. Let's fix the wire and here on the other side. Okay, let's just fix it. Okay, and this one will be here on the other side. Okay, so here to properly connect our wires and to make our schematic presentable. So let's just move it here. Okay, so this will be our schematic for our experiment number 3. So this is the servo motor and this is our Arduino microcontroller. So now let's proceed to our Tinkercad. For our actual circuit simulation, we'll be creating a new circuit here in Tinkercad. So I'm just gonna have to make a new circuit here, and then what the circuit that we've created using fritzing, we'll be creating it here as well. So we're gonna have to search for another component. So Arduino. Okay, let's search for Arduino. So let's search for Arduino here. So Arduino Uno. Okay, so this one. So we're gonna be using an Arduino, and then we're gonna be. So now for our actual circuit simulation, we'll be considering Tinkercad. So we'll be using an Arduino Uno microcontroller and a microservo here. So it's either of the two, the black one or the blue one. It's up to you. So we don't need a breadboard anymore because the servo motor will be directly connected to our Arduino microcontroller. So based on our schematic here, as you can see, okay, based on our schematic, pin number 9 is connected to our signal input. So let's go back to our Tinkercad. So here, ground will be connected to our connection here, ground for the Arduino. So let's connect it properly here. Wait a moment. So, yep. So after that, let's connect the power, which is for the 5 volts here. Okay, 5 volts. And then let's connect our input. So our signal will be on pin number 9 of our microcontroller. So that's our connection for our Tinkercad. Now let's proceed with our code. So now for our task to do, we aim to create a program for the microcontroller that will control the angular displacement of the motor, of the servo motor, by sending pulse with different width that correspond to the angle of the servo motor. So we'll be using our code here. So as you can see, we'll be using hashtag include servo.h, okay, and we'll be declaring this one int angle is equals to 0. So servo will be using this command as well, servo my servo. So this is used to create servo object, okay, to control our servo. So under void setup loop, we'll be initializing, okay, we'll be initializing our serial monitor here. So let's put a note here, initializing serial monitor. And then we'll be using myservo.attach9, which means that we'll be using the pin number 9 of our microcontroller, of our Arduino, as the input for our signal for the servo motor. So then under our void loop here, we're gonna have angle is equals to serial.parseInt, which will allow us, okay, which will allow us to input the desired angle of the servo motor. Okay, And then we're gonna have an if statement here wherein it will tell that if the angle is greater than 0, it will perform this command here wherein it will consider my servo.right angle, meaning it will set the servo position according to the scaled value or according to the input value on the serial monitor. The next one will be printing in the angle encoded in the serial monitor, and then we'll be setting a 15 milliseconds delay, okay, for the servo motor to get on the desired angular displacement that we've set. So with this, we'll be running our code. So let's focus on the servo motor here as we run our code. So now let's start the simulation. So I want you to focus on our servo motor. So let's start with, wait a moment, let's zoom in. Focus on the servo motor. Let's start with the value of pin. Okay, so just wait for the serial monitor, okay, to acknowledge the value. So as you can see, the angular displacement changed when we input 10. Then let's try 40. Okay, it takes time. Okay, that's the 40-degree angular displacement of our servo. The next will be, I think, 65. Okay, as you can see, it changed. Then let's go ahead to 90 degrees. This is a right angle. So let's wait for it. Okay, as you can see, that's the 90 degree of our servo motor. Then let's increase the value. So 120 degrees. Okay, so that's the 120 degrees of our servo motor. Okay, and next one will be 150. Okay, wait for it. That's the 150-degree angle. And then let's proceed to 180 degrees. Okay, great. So that's the angular displacement of our servo motor. Let's try 1. As you can see, it the servo motor rotated and it goes back to the 1-degree angle of the servo motor. Then let's go back to 180. Let's try. Okay, that's a full rotation. So from 1 to 180 degrees, that's the evidence that the servo motor angular displacement can be controlled using our Arduino code. So why didn't we input 0? As you can see here in the code, in 0 cannot be 0 cannot be encoded in the serial monitor because we'll be starting with 1. A 0-degree angle is not valid for this code. Only values, okay? Only values from, as you can see here, if angle. Our if statement is, we're providing a condition wherein angle is greater than 0. So it's between 1, okay, between values of 1 and, okay, let's wait for it, 1 and 180. Okay, so that's the end of the task 1. Let's proceed to the second code, to our task 2. Okay, so now we're done with the first task, which is to be able to control the angular displacement of the motor by ascending pulse with different width values, okay, that correspond to the angle of the motor. So that's the first task. So we've already inserted the code here. For the second one, we'll be considering a code that will automatically control the change in the angle of the servo motor from 0 to 180 degrees. So that's a common application for, let's say, for our factories and for our industries. So let's have our Tinkercad here. So we're now considering this code. So first one is servo space servo underscore test. So this will initialize our servo as the object for the connected servo. So we'll be declaring our angle here, okay, which means that the starting value is 0, Then under void setup, we'll be using servo underscore test that attached. So this number 9 here assigns the number of pin for our input signal, which is here, as you can see here, the signal of the servo is connected to the pin number 9. So under void loop, we'll be considering this for statement, wherein given angle is equals to 0, so if angle is less than 180, there will be an increment for the angle value. So there will be an increment of 1 for the angle if the angle is less than 180 or lower than 180. So let's say, for example, our angle starts with 1, then it will increment with the value of 1 up until it reaches 180 degrees. Okay? So this command is used to move from 0 degrees to 180 degrees. That's the common logic behind that. So we'll have this one, servo underscore test at right angle. So this is a command to rotate the servo to the specified angle that we've assigned in the code. So we'll be considering a delay of 15 milliseconds for the servo to perform or to go to our specified angle. So we'll not be inputting any values in the serial monitor here anymore because the code allows us to automatically control the angular displacement of the servo motor. So we'll be considering again a delay of 1000 milliseconds or 1 second for our next task, which is for our next for statement, wherein if angle is equals to 180, meaning after this task, okay, after this command, if our servo motor has successfully reached the 180-degree angle, there will be a 1 second delay, and then it will perform another for statement here, wherein if it reached 180 degrees already, then our for statement is will be commanding our controller to control the servo motor, wherein it will move the angular displacement from 180 degrees to 0 degrees. So how can we do that? We can do that by having a negative increment here. Okay, so compared to this one, which is just a 1 increment, okay, positive 1. So this means that it will be slower. The process of changing the angular displacement from 0 to 180 will be slower than the process of changing the angular displacement from 180 to 0 because the increment here is -5. So this will be faster because the increment is larger than positive 1. So once the angle reaches 180 and the angle is greater than 1, okay, which is our initial value, okay, initial value for the angle, so it will have an increment of -5, and then the servo motor will start to move from 180 up until it reaches 0 degrees. So this command will perform that task. So command to rotate the servo to the specified angle that we've selected, and we'll be considering a delay of 5 milliseconds. And after that, we'll be considering another delay of 1 second, and then the loop code will repeat. Okay, it will just repeat, just like in common applications in the industry, wherein automation of motors are applied and observed. So now we'll be running our code. So focus on our servo motor here. Okay, so let's start the simulation. Okay, as you can see, the first for statement is being performed by the servo motor. So, yep, as you can see, just like what I've said, the second for statement will be performed quickly compared to the first for statement. So, as you can see, that's from 0 to 180. Okay, then 180 to 0. That's 0 to 180 slower than 180 to 0. Again, 0 to 180 slower than 180 to 0. So that's the logic behind our task 2, which is automatically changing or controlling the angular displacement of our servo motor. So that's the end of our task. So let's go back to our Word file. So with that, that concludes our laboratory activity number 3. So we're gonna have here our running code. So for the first part, for the second part, and then we're gonna have here our schematic, our working sketch using fritzing, and our actual circuit assembly in our Tinkercad. So again, my name is Rica Casabuena from ECE 41 of the De La Salle University Das Marinas. So don't forget to subscribe, and I hope you learned a lot from our experiment today. So see you on our robotics laboratory episodes. Bye!